Imagine walking in heavy rain, but instead of using an umbrella, you switch on a powerful laser to block the falling drops. Sounds futuristic, right?
A laser looks like a solid line of light, but it's actually just photons traveling in a tight beam. It doesn't have physical mass to push raindrops aside.
So the first problem appears quickly. Raindrops are heavy compared to light. A normal laser can't physically stop or deflect them. But what if the laser was extremely powerful, strong enough to heat the air around it, creating a protective hot column?
When air heats rapidly, it expands and can push raindrops away. This is the same effect used in military laser systems that clear fog or smoke. So in theory, a powerful enough laser could create a small dry zone above your head by evaporating drops before they reach you.
But here's a huge problem. Evaporating rain requires enormous energy, far more than a handheld device could ever produce.
Sure. A typical raindrop has thousands of times more mass than the laser's photons. So the laser must heat each drop fast. If you tried this with a normal handheld laser, nothing would happen. The rain would pass straight through like the beam wasn't even there.
So what about industrial lasers used to cut metal? Even those focus their energy at a point, not along a tall vertical sheet like an umbrella.
Even if you managed to create a tall wall of laser-heated air, it would only protect you from a tiny area directly above the beam.
The umbrella shape is the real challenge. Umbrellas stop rain by creating a physical surface. Light cannot create that solid surface. To mimic an umbrella, the laser would need to create a dome of superheated air above you, deflecting every raindrop around it.
But that dome would be extremely hot, hot enough to burn anything nearby, including your hair, your clothes, even your skin.
To evaporate rain instantly, temperatures could exceed several thousand degrees. That's hotter than boiling metal.
You'd essentially be standing under a tiny, portable furnace. Not exactly the safest alternative to a $5 umbrella.
There's also the issue of diffusion. Hot air rises quickly, so the laser-created column would drift upward instead of staying above you.
Even a tiny breeze would break the laser shield instantly, letting rain pass through without resistance.
And why? So while the science sounds amazing, the practical side falls apart quickly. Rain is simply too chaotic.
But don't lose hope. Scientists are experimenting with plasma lasers that create ionized air channels, which might one day mimic a force field.
These plasma channels can guide electricity and even redirect lightning, proving that light can shape the air in powerful ways. But these systems need massive equipment, cooling tanks, and dangerous voltages. Definitely not something you can carry on a rainy walk.
Engineers also tested lasers to clear fog for airplanes, but even that requires enormous energy and works only for a small area. If clearing fog takes so much power, imagine the energy required to clear falling water. Thousands of drops hitting every second. Even if you created a vertical laser barrier, the rain falling diagonally from wind would still reach you from the sides.
And if your beam was strong enough to actually melt or vaporize droplets, it would also melt everything else around you. But the idea isn't completely useless. Research into laser-air interaction helps develop future energy shields and better weather technologies.
So a laser umbrella might sound cool, but in reality it would be dangerous, inefficient, and probably illegal to use in public.
So no, you can't use a laser as an umbrella. But the science behind it reveals just how powerful light can be.
Maybe one day we'll have real protective domes made of plasma or magnetic fields. But for now, we still depend on simple umbrellas.